Okay, hello and welcome everyone to another Applied Flow Technology webinar. My name is Nick Fastine. I'm a business applications engineer here with AFT, and today I'm going to be walking you through how to import a model. That way you can save some time, avoid some issues, and hopefully improve your modeling results. So we'll look at file imports from both AFT and non-AFT sources, but before I get ahead of myself, let's go ahead and take a look at our agenda. So the first question you might have is why import your model? Obviously, if you're here and you're watching this video, you probably have some ideas of why you would want to import your model into our applications. We'll look at the types of files that AFT software can import. So we'll look at importing from other AFT applications and then some of the file formats that you might find in CAD software or pipe stress software that we can bring in. We'll go through an example of importing a PCF file, go through the process itself, kind of look at each of the points individually and see what each of the settings means. And then finally, how can we clean up that model for preparation and doing our hydraulic analysis. So an important theme kind of the webinar is that importing your file and importing your model is going to improve your model development process, but it's not going to completely replace an engineer. You still need to specify a lot of different things, confirm your assumptions, confirm that your model is specified correctly, and then from there, you can begin doing your hydraulic analysis. So let's jump into it. Why would you want to import a model? The common application is that you want to save time. Time's money, especially engineering time, which can be particularly expensive. So if we have a system in place in another application, why do we want to redo all of that work that we've already done? So here we actually have a case study that was submitted for our annual Platinum Pipe Award. And in this case, they were looking at data center surge safety. So they had 11 different cases of HVAC systems that they were trying to import into AFT Impulse to perform a surge analysis. So they were looking, in this case, at a chilled water circuit. Again, they had 10 other systems they were looking at. This was their original model as they had it built or as they inherited it from a client, and then they were able to bring that into our software, into AFT Impulse. So you can imagine saving a lot of time in terms of transitioning all of the pipe lengths, pipe diameters, the elevation information into AFT Impulse. That's a great leg up compared to completely drawing the model from scratch. So saving time, it's in both your best interest as an engineer. You get to work more efficiently and you get to avoid some of the menial tasks of drawing and defining your model. You can also import a model to perform additional analysis. So this gives you more flexibility in terms of what things you can analyze for a particular model that you have built. Again, we have another case study submitted for our Platinum Pipe Award. This was a winner where here they were looking at their AFT Fathom model, and then they could bring this same model into AFT Impulse, transitioning from their steady state analysis to a surge-oriented analysis. They were then able to develop a lot of different scenarios, looking at different cases like pump starting and pump stopping, pumps tripping, what happens if these vacuum breaker lines are open or not, and then also if you add lag. So again, especially if you are a AFT user of AFT Fathom and you're looking at a surge analysis, it's very convenient to bring that steady state model that you've invested a lot of time and effort into an application like Impulse, where you can then define your transients on top of that steady state model. So we'll go through an example of that in the webinar a little bit later. The final reason you might want to import a model, among others, is to reduce input error. So by transitioning your model from something that you already have specified in another application into an AFT software program, obviously you're removing the human error of manually specifying things like elevations, pipe lengths, diameters, etc. However, it's important to consider that the kind of thesis of modeling garbage in equals garbage out, that's always going to apply if you're taking a system defined in another application and importing it into AFT. Again, it's not going to check for those errors for you, whether those be unit errors, specification errors, differences in elevation, everything like that. So it's important to always consider that as you bring your models in from another application. As I mentioned, file import is not going to be comprehensive. It won't completely replace an engineer, but it will give you that foundation, that solid starting point to then build upon your model and then ultimately perform your hydraulic analysis. So some of the things that we will bring over include pipe lengths. We'll look at that. Pipe diameters, which we can then map to specific pipe materials, either a material database that you have created in AFT software or one of the default that we provide to users. Elevation information. So again, how is it changing vertically? The connectivity. So if we have branching pipes, connecting pipes, how are they connected to different valves, area changes, things like that. And then other junctions, as I mentioned, it will bring in valves, elbows, bends, all sorts of other things like that. So now we have a good understanding of why we would want to import a model into AFT software. So what types of models can AFT import? First thing that we can import is other AFT models from other AFT applications as well. So the first thing that we'll look at is called the merge function, which is found under the file menu under merge. What this does is it imports the selected file into your open file. An application of this might be if you are splitting up the workload of drawing your model into AFT, where someone might have the pumping section and someone might have the heat exchanger network. You can then merge those two models together without the kind of error-prone approach of trying to manually copy-paste information or avoiding redundant work. So let's jump into the software and we'll take a look at what the merge function looks like. So here we have in AFT Fathom our pump supply. This is for merge. So this is again simulating a case where I would have been responsible for building out this pumping case with all of these pipings, the topping tank, all these elbow connections. What we want to do is connect this pumping case to our heat exchanger network, and we can do that using our merge function. So here we're in the base scenario. We can go up to File and then Merge, where here, if we take a look, we have a few different files available to us. You can do this with any AFT Fathom model, obviously. So if you have more complex systems that you want to bring together into a single case, you can do that as well. So here we have the model that we have open pump supply for merge, and we're going to import or merge this heat exchanger network. So if we select this file, we can hit open, and we get this message telling us that the merge was completed. Any duplicate pipe and junction numbers in the model were changed to ensure no conflict with the current model. So let's say that we drew our original case 1, 2, 3, 4, 5 for our pipes. This is just saying that we are going to change those numbers for you because we can't have two pipe ones in our specification. So we have no conflicts. If we hit OK, we've brought over our model. All we have to do now is select it, and we can make those connections. And here, if we built out scenarios in our case that we merged things over into, obviously those scenarios would also see that merged file come in. So one caveat is when you are merging a file into another file, that it will only bring over this base scenario. Again, it's not so complex that it can manage the different scenarios in each case. So just something to understand, especially if you're trying to leverage this feature. So that is the merge file. We'll go ahead and save this as our new merged file, and we'll use that in our next step. So as we saw with the different case studies, we can also transfer files from application to application. So in this case, we can transfer it from Fathom, which we would have done all of our steady state analysis. We would have done things like pump sizing or pipe sizing, and now we can bring them into AFT Impulse where we can do our water hammer analysis. We've similarly seen cases where people will bring in a Fathom system into our compressible flow program AFT Aero, where they might model something like a steam blowdown for cleaning out the pipes. So again, people can be creative, but in most cases, I would focus on the transition from Fathom into Impulse, which we'll look at here. So to access it, you go to File, Open. You go to the folder that it's hosted in, and then we want to change the file type down here. So here we have the file in Fathom. We'll go ahead and close that. Now if we open up AFT Impulse, if we go to File up here, then Open. So we will go to our model file folder. And here we can see that we don't have anything available because we don't have any AFT Impulse models in this folder. But if we click this drop down, we can select AFT Fathom folders, where here we can select that merged file, or if we select all, we could see any other types of files in here as well. So this would open up the door for things like Arrow or Extreme, or if you're in any other application, you can open up from any other application. So here we'll open up our merged file. Hit OK. It'll give us a warning that we're opening a Fathom file into Impulse, and we might lose some data. We can hit OK. We have to feel comfortable with that because some things are just unnecessary. Here on the left, we can see that it brought in our model, and here we're getting a message saying that there were some library items that we had in Fathom, essentially things that we've saved, like the pump curves for our pumps or the resistance curves of our heat exchangers, and we need to bring that over into our new application. So for items not found in library, here we want to set all items to add to library, and what that's going to do is create a redundant copy in AFT Impulse, and we're able to reference those in the future and reference those as we use this model going forward. So I changed this to add to library, then click apply, and then these actions all changed here. Now when we perform the action, we've saved all of our library entries to AFT Impulse now. So when we save the file, it'll be in this Impulse format. Do we want to rename the file with the Impulse extension? We want to say yes. And here it's giving us a heads up that because now we're doing transient analysis, some of the resolution of the model that we had before is unnecessary. So we can try to combine different pipes and combine different junctions, and that can help improve our runtime. So in this case, we'll say no because we're going through our example. And again, we can see that all of our specifications have brought over, all of our scenarios have been brought over, and then we could perform our surge analysis. So let's say we go into a pump. Here we can see all of our pump curve information is brought over. We could add a transient event. For example, we could do a ramp up where we say over 10 seconds, we go from the pump at 0 all the way up to 100. Alternatively, if we wanted to look at things like a control valve, here we have a volumetric flow rate control valve where we can go to this transient tab and we can specify our transient data. So again, if we have that basis in AFT Fathom and we have our steady state model already, it's pretty simple to bring that into a transient tool, avoid all of the redundant work, and then we only need to specify those transients on top of it. So very valuable, obviously a time saver, and one of the reasons that that case study won in its year. Again, to recap, that's from File, then Open, where we want to change that file type here in the lower right. So we've looked at how we can import AFT files from either merging them or by bringing them from other applications, but we also have different piping layouts that we can import. So this is accessed from File, then Import Piping Layout From, where we have these 4 different options. So we have piping component files. In general, these will be generated from CAD programs, especially if there's an isometric drawing. Caesar 2 neutral files, which are typically supported by pipe stress analysis applications, so things like Caesar 2, AutoPipe. GIS shapefiles, where the shapefile should include piping specifications, and there's other layers where GIS will also have things like valves or reservoirs where you would want to import those in phases. And then EPANET, which AFT applications can also export to. So we can import our piping layout from these 4 sources, but we can also export our piping layout out to EPANET, useful if you're trying to review a profile or something like that. So those are the 4 options that we can perform an import on. We aren't going to go through the process for each of them, but a lot of the steps are going to be the same. So with this example, we're going to focus on a PCF file, and we'll go through our, I believe, 6 steps of importing that PCF file, and then what additional things would we need to do to clean up that model, get it ready for hydraulic analysis, and then ultimately perform that hydraulic analysis. So the first thing we'll do is create a new AFT file. We want to select the file to import. We want to arrange it and rescale it because, as we'll see, it can be a little messy in terms of how it's brought in. We can reassign different junctions or adjust them. We can link pipe materials. Again, if we know a particular pipe material, we can instead reference the AFT library version. And then finally, we can perform that import. So here we're still in AFT Impulse, but this process works, whether it be AFT Fathom, AFT Aero, Impulse, or Extreme. Again, it'll all follow the same procedure. So if we go to File, what we'll do first is create a new model. So we'll go to File and then New. We don't care to save those changes. If we did save this file, it would save a new version. So we would have a Fathom version and then an Impulse version. In this case, we don't care for the model because it's just an example. And here we have our brand new model, our brand new workspace. Again, the place that we can import the piping layouts from comes from File and then Import Piping Layout, where here we have those 4 different options that we discussed. So we'll start with a piping component file. And here we can see on the right that our quick access panel, which typically shows our scenarios and other information, is now our import piping layout wizard. So the first step in performing the import is selecting our file. So here we're going to click on this button with the 3 dots. That'll bring up a browser, where here I've just saved everything in this downloads folder for now. So we can open up this PCF folder. If we hit OK, our application will report all of our different PCF files from that folder. When we select it, we can get a preview here on the workspace. Another useful thing is if you have many different PCF files in a particular location, you can go through each of them one by one. That way you can ideally identify your system as you're going through the process, again, if your naming procedures aren't very clear. So there's a few different things that we can do with the file once we have it selected. We can rearrange it on the workspace by clicking this button up here. We can move it around. We can also rescale this. So by default, we have an auto scale option. In this case, it's 8% of the original scale. If we uncheck our auto scale, we can see that by scrolling out, we can see it's much, much larger. So when we zoom in, we can see all of our pipe connections and all of our junctions. And obviously, if you're familiar with our software, this can be a bit sparse for your model. So you can change this manually with this preferred scale. Let's say we make it 40. And we can see that it jumps around, but if we click this button for auto zoom preview, then it'll rearrange our preview based on how we change this scale. So let's say now I make it 80. We can see that our zoom went out to 6%. And if we go back into 40, we can see it rearranged back to 12. So scaling is very important because in a lot of cases, the auto scaling or the density of the system might be okay in a CAD program, but might cause issues in our software. So if we look at a different PCF file, let's say this one. So here we can see that we have a lot of overlap of different junctions. So it's very hard to read, and it's also going to be very hard to interpret this input because it's unclear how these pipes are all connected. So here, if we turn off our auto scale and we zoom in, you can see it's still going to muddy it quite a bit, and you could even expand it further and say 150, where we're getting closer and closer to what we want our final result to look like. So scaling, pretty vital in terms of bringing a model in cleanly, and probably the most important option for what we're going to talk about today. So we'll go back to the simpler system, where here we can see that we have our different junctions being brought in as well. So here, if we select this valve, we can see that it was detected as a valve in the PCF file, and it's going to be brought in as a valve in AFT. If we look at this area change, it's a reducer that's concentric, and that's brought in as an area change. You can also modify these selections. So let's say that this valve in your hydraulic system is a control valve. You can select this drop down and change it from a valve up to a control valve or a check valve or any other object that we have here. And here we can see that it gets updated on the workspace as well. There's a lot of information in a PCF file that we don't necessarily need, but we can also bring that information in. So for example, with this valve, here the most important information is this inlet and outlet elevation. For the most part, we bring in the inlet elevation to define the elevation of this component. And then here we have the points in 3D space and 2D space, which we're converting to create this drawing. Here, if we check Show Advanced Properties, this is additional information that we don't need for the hydraulic model necessarily, But again, we have this information and that can be imported into our model. We can do that with this little setting down here, import data to notes field, where if we check this box, we'll see when we perform our input and we go look at the valve notes, we'll be able to see all these specifications. What that can do is if we know the item code, you can then use our built-in search function and that can help you find that valve in your hydraulic system instead. So we'll close that off. Some other things that we can touch on, so we can also ignore pipes, whether that be based on length. So if you have very small pipes, you could remove those. That could be useful if you have very small connections between components, for example. You can also ignore pipes of diameter less than that, and then this will be the count of how many pipes are you ignoring. AFT will ignore some information already just through the import process. So if we check this box to show ignored objects, we can see that we're not bringing in information like welds, gaskets, and bolts and flanges, because those aren't going to inform that hydraulic solution. Let's see what else. So showing the pipes and junctions and previews, those should be shown. This setting to combine pipes when possible. If we uncheck this, here we can see on this pipe, for example, we have orange, blue, orange, indicating this would be imported as 3 different pipes. If we combine them, it's recognizing that there's no distinct loss that's going to occur at these connections, and we can import it as a single pipe. So helping you clean up your model in this step. Import bends as pipes, we'll look at a different import file type for that one. But in essence, if you have bends, you could import those as pipes instead. You can ignore fitting lengths. So if you have fittings and using equivalent lengths to try to account for that, you could ignore that and then import data to notes field. As we saw, we'll show you what's included in this property window. So that will copy over to the notes field in your specific junctions or in your specific pipes, which we'll see in just a moment. So we've looked at how we can change those junctions. We can also change our pipes to improve our model and provide things like roughness information as well. If we click link materials, here we can see that we have the materials reported by the PCF file. If we click this drop down, you can actually see which pipe it's referencing, which can be valuable. And here at the top, we can change the material associated with this material. So let's say that in our PCF file, we had ANSI steel. We could go into here, assign ANSI steel, and then assign our pipe size. So here we could say it's 8 inches and we want schedule 40. So what that's going to do is as it imports this, it's going to assign that pipe size to all of these different pipes, saving us a step going into the next few phases of modeling. So if we hit OK, now our model is all fully defined. It's all ready to go. If we click import, we can see that it builds out all the different junctions, all the different pipes, and our model has been brought in. So if we close our import, we can see that we're not ready to run our model. Obviously, we haven't specified things like a fluid, but again, this provides a stronger foundation than nothing to specify how is our piping system laid out. So if we go into this pipe, for example, we can see that it updated to our 8-inch schedule 40. If we go into our notes tab, we can see that we have our information brought over from that PCF file. Here in this case, we can also always find the length and diameter. So here, this diameter of 10 inches, maybe that's inconsistent with the 8 inches that we had selected. So again, garbage in equals garbage out. Even in the process of performing this import, you can introduce errors. So always stay cautious in terms of your changes. With this notes field, again, you can also search this from the search bar up top, and that should be able to identify things like your item code as well. We also saw with the valve how that was brought in as a control valve, again, saving you the step of replacing that later. So this was our first import of our PCF file. Let's say that you have multiple PCF files, sort of like we had multiple Fathom models for when we were building out that cooling water system. You can also import additional files on top of this. So you could import another PCF file. In this case, we'll look at importing a Caesar2 file and see how, again, the process is very similar, but slightly different. Here again, at the top is our folder browser, where we'll go and select our folder from downloads, and then here are Caesar2 files, where again, we can go through and we can preview each of the different cases. So here we'll look at hammer, where we can rearrange this. We can scale it as we did before. We can ignore pipes as we did before. Again, a lot of those same settings are the same. So here what I would want to highlight is this setting to import bends as pipes. If you check this box, we can see that we remove those different elbows, which can clean up our model, especially if we're doing something like AFT impulse, where pipe length can very dramatically impact that runtime. What we might have to do instead, if we import our bends as pipes, we go ahead and perform our input or our import. From a hydraulic perspective, we now see that we have a single pipe running from this valve all the way to whatever this discharge condition may be. It's important to consider that AFT is not going to automatically consider those losses from removing those elbows, which we can add back by going into the pipe itself, adding fitting and losses, and here we could add, for example, our 10 90-degree bends. What that would do is add our K factor, so that way when we're considering pressures and flows, we can account for that loss as well. And so if we take a look back at our 6 steps for importing model, again, we started from a fresh workspace, but you can always import on top of an already imported model. We selected our different files, in this case, all from that downloads folder, and we could see how we can select that file and use that preview function to identify our system. We want to arrange it and rescale it. We saw with the very complex system with all those overlapping elbows, we want to scale the model sufficiently to avoid that overlap. In a lot of cases, these programs might not have the same junctions as we do in AFT programs. So things like check valves or control valves, you might want to adjust those junctions and assign those during the import process. Pipe materials, we saw that we can reassign our pipe materials to something specified in our AFT databases. Here again, it's important to be cautious that we are transitioning to the right diameter, because that can introduce error into your model through that import process, and garbage in equals garbage out. We don't want to continue building upon that model. Finally, you can perform that input or that import, and then from there we can try to polish the model a little bit further and prepare it for hydraulic analysis. So how do we clean up that model? There's a few different things we can look at. The first thing is adding different boundary conditions. So we have to have pressures or flows that bound our fluid solution. We can see here in both cases, we don't have any terminating condition here. This could be discharging to atmosphere, it could be discharging to a pressurized tank. Maybe we have a positive displacement pump that's feeding constant flow to this piping system. At this point, from our import, we don't know that information. So we have to give those boundary conditions to have a hydraulic solution. We also want to add loss values. Again, in the hydraulic world, we want to consider every possible loss from friction from pipes, from elbows, from valves, from anything. So we want to account for that in our system. We saw how with the Caesar2 import, if we import our bends as pipes, we want to add those elbows as fitting and losses into the pipe itself. You also want to specify the losses in junctions like valves. So for example, we have these valves that we brought in from our PCF file. If we go into them, here we can see that the elevation information is defined. All the notes came in, but we don't know what kind of pressure losses we're going to see through this valve. So we could define a CV, we could define a K factor, again, more traditional modeling approaches. Let's say that we have a lot of different valves that we want to change the loss of. We could use a feature like global edit or an Excel change set to mass modify our input. So a little demonstration, let's say that all of these valves are all the same and they all have a CV of 1,000. One option is you could open up each valve, you could type in 1,000, hit OK, go one by one. Or what we can do instead is globally edit them, which means I can highlight all of these, I can select all of my valves. I can, let's first finish our import. And here, if we go up to global edit, we can go to global junction edit, then valve. Here we have the valves that we have selected on the workspace, selected for us over here. And what we want to do is select what data we're going to push to those valves. So if we hit select valve data, this is just a template where we can specify anything we need in here. Then that change will select and that will apply to the valves that we have selected. So here we can set our CV to 1000. If we hit OK, here's all of the different parameters that we could push that change to. And then here we want to select this user specified CV. If we hit apply selections, we can hit OK. And now we can see in these different valves, all of our CV is equal to 1000 without modifying other conditions like our inlet and outlet conditions, which should be different for each of these valves. So global edit, that can clean things up very well. We also have different features for select special. So here, let's say we wanted to edit our pipes based on diameter. Here we can look at global pipe edit and we can use this special button to determine which pipes we want to select. Select special gives us some flexibility in selecting different objects. So we could look at what things are closed in the model, if there's any special conditions, a number range, again, a lot of different things. What I would highlight is this pipe input properties, where we could look at the inner diameter, let's say anything from 5 inches to 10 inches. We can select all those pipes, and in this case, that's all of them. And then we could go through that same global edit process, narrow in, and push those changes. So let's say we didn't import those materials. We could look at everything from 7 to 8 inches, apply those changes, make them all 8-inch pipes, everything from 8 inches to 9 inches, again, performing that same change. So a lot of flexibility, a lot of power in this select special capability. So to kind of recap, with importing, this is really just the first step in building out your hydraulic analysis. We have all of our pipe lengths, diameters, elevations, but we also want to, again, define those boundary conditions, add losses, and then finally start building out our different scenarios. And then performing that hydraulic analysis, that has its own rules, which if you're interested in these webinars, we have plenty of other webinars that can walk you through that process. So this is just the first step. Again, you want to make sure your input's very good and don't build your model on top of bad input, making poor assumptions. So relatively quick webinar, let's go through and summarize what we've learned. First, importing a file is a great starting place for hydraulic analysis. We saw how it can save time, importing up to thousands of pipes. We can perform additional analysis, especially if we have a steady state system that we want to then perform a transient analysis on. And it can also help us reduce input error by taking those elevations, those pipe lengths, those pipe diameters, which are hopefully checked in that other application, and bringing them over into AFT software. So it's always important to double check that input because, again, that import process can also introduce issues as well. We saw how we can import from other AFT applications. Again, the most common one being AFT Fathom into AFT Impulse, and we looked at how we can import Caesar2 neutral files, piping component files, GIS Shapefiles, and then EPANET files, where each is going to be a little different, but are going to follow generally the same process. We saw how we can map materials and junctions during import, saving us some steps. Instead of doing global edit after the import, we can just assign those materials to begin with. And then finally, have realistic expectations. Our file import is just a foundation to start, but there's still going to be a lot of legwork to finalize and develop that hydraulic model. So hopefully you learned something new. Of course, if you have any other questions, feel free to send us an email at webinars@aft.com, and we're happy to send a response. As we come up to the end of the year, if you have any ideas for future webinars, we're always looking for future webinars. Feel free to submit a topic of interest to webinars@aft.com. That could be an industry that you're in, a particular problem that you had, a common issue that you want to train more engineers in. Feel free to shoot an idea, and we're happy to try to accommodate. Again, I was your host, Nick Vastine. If you have any other questions, feel free to reach out, and we hope to hear from you again in another AFT webinar soon enough. Thanks for attending.